Ever wish you could like tweak the audio settings of reality itself? That's kind of what today's deep dive is all about.
Oh, wow.
We're going deep into the cutting edge of sound technology, where
Yeah.
researchers are basically doing just that.
Cool.
So
Okay.
get ready for some serious aha moments, because we're talking about AI that can understand music,
Wow.
devices that can communicate underwater,
Okay.
all kinds of mind-blowing stuff.
That's awesome.
I've got a stack of research papers here.
Cool.
And
Yeah.
I'm so excited to like dig into these with you.
Yeah, me too.
So first up,
Okay.
let's talk about how AI is changing the game when it comes to understanding who's talking in audio recordings. One paper that really stood out to me was
Yeah.
language modeling for speaker diarization in telephonic interviews.
Okay.
Now, you might
Yeah.
be wondering, what in the world is speaker diarization?
Yeah. What is that?
Basically, it's figuring out who said what
Okay.
in an audio recording.
Oh,
So
got it.
think about like a meeting with multiple people.
Yeah.
You need to know who contributed which ideas.
Mm-hmm.
And what's really interesting about this research
Yeah.
is that it uses linguistic cues
Okay.
to identify speakers.
So what do you mean by linguistic cues?
It means the actual words that people are saying
Oh, okay.
along with their breath pattern.
So it's not just like how they
so
sound.
It's not just
Yeah,
like
what
the
are-
tone of their voice, but like the actual content of their speech.
That's it.
And that's a big deal
Yeah.
because traditional systems, I often struggle when there's background noise or when speakers have similar voices.
That makes sense.
This new approach is way more accurate
Okay.
because it considers not just how someone sounds, but also what they're saying.
So it's like the AI is getting a deeper understanding of the conversation.
Yeah, like it's actually listening to the meaning.
Wow.
And that makes me wonder, could this technology also be used for things like analyzing podcasts
Okay.
to find specific topics based on who brought them up?
Like you can search for a podcast
Yeah,
based on a topic.
exactly.
That'd be awesome.
That would be so helpful for researchers or anyone trying to learn about a specific subject.
Mm-hmm.
Okay, let's move on to something that sounds straight out of science fiction.
Okay.
The quest for perfect 3D sound.
Ooh.
We've got two papers to unpack here, both tackling the challenge of creating realistic 3D audio on headphones.
Cool. Yeah.
Before we get into the specifics of each paper, can you explain what Ambisonics is?
Yeah, sure.
I'm guessing not everyone listening is an audio engineer.
No, probably not.
So
Eventually.
Ambisonics,
Yeah.
it's basically a method of recording and reproducing sound that captures spatial information.
Okay.
It allows you to experience sound coming from all directions.
So it's like taking a snapshot of the entire soundscape.
Exactly.
That makes sense.
Yeah.
Now back to these research papers.
What makes them so groundbreaking?
Well, the first one focuses on optimizing ambisonics
Okay.
to make 3D audio more accurate, even when you have fewer microphones.
Fewer microphones, more immersive sound.
Yeah,
That's a win in my book.
definitely.
What about the second paper?
The second one is all about improving how we perceive sounds coming from specific directions.
Okay.
It uses a technique called BSMI MAB LSS.
BSMI Magla.
Yeah, it's a mouthful.
Okay.
But it basically focuses on matching the subtle differences in how sounds reach our two ears.
Oh, interesting.
Yeah.
So it's kind of like tricking your brain into thinking the sound is really coming from a specific location.
Exactly.
And this is incredibly valuable for things like virtual reality and augmented reality,
Yeah, for sure.
where immersive sound is crucial for creating a convincing experience.
Absolutely.
Can you imagine exploring a virtual world where you can pinpoint the exact location of every sound?
That would be incredible.
It would be like stepping into another dimension. Okay, this next one might seem a little out there,
Okay.
but it's actually incredibly important.
Right.
Underwater communication.
Underwater communication.
I have to admit, I don't think about this much in my day-to-day life.
Yeah, it's not exactly something that comes up in casual conversation,
No, not really.
but it's a huge area of research
Okay.
with some mind-blowing potential.
I'm intrigued. Tell me, why is underwater communication so challenging?
Well, sound behaves very differently in water.
Okay.
It travels slower
Mm-hmm.
and loses energy more quickly. Plus, the ocean environment is constantly changing,
Yeah.
which makes it really hard to send clear signals over long distances.
It sounds like trying to have a conversation in a hurricane.
Pretty much.
So how are researchers tackling this problem?
Well, this paper proposes a really innovative solution,
Yep.
multi-layered surfaces that can reflect and redirect sound waves underwater.
Multi-layered surfaces, so they're like...
Like acoustic mirrors. They can focus sound waves and extend the range of underwater communication.
That's brilliant.
It's like building an underwater internet for sound.
Wow, what kind of applications are we talking about here?
Well, think about being able to communicate with underwater vehicles,
Okay.
exploring the deepest parts of the ocean,
Wow.
or creating vast sensor networks to monitor marine life
Okay.
and track changes in the ocean environment.
That's amazing.
The possibilities are pretty amazing.
Yeah, when you think about it, it's like we're on the verge of unlocking a whole new world of underwater exploration and discovery. This is why I love these deep dives.
You too?
You never know what fascinating rabbit hole will go down next.
Exactly.
Now let's switch gears and talk about something that's becoming more and more prevalent in our lives.
Okay.
AI-generated audio.
AI-generated audio.
Specifically,
Yeah.
how researchers are trying to make it sound more human.
More human.
The paper we're diving into here is called AGAV-Rater, adapting a large multimodal model for AI-generated audiovisual quality assessment.
AGAV-Rater.
Yeah.
Okay.
This is an important area of research because AI-generated audio and video are becoming increasingly common,
Right.
especially for things like dubbing movies and TV shows. But there's a big challenge.
What's that?
How do we ensure that this synthetic content sounds natural and doesn't fall into that uncanny valley?
Right, the uncanny valley.
You know, like those AI voices that sound a bit robotic or stilted?
I know exactly what you mean.
And that's where AGAV-Rater comes in.
Yeah.
It's a tool that analyzes the quality of AI-generated audio and video, taking into account things like how well the audio matches the lip movements, how natural the voice sounds, and how well it conveys emotions.
So it's like a quality control expert.
Exactly.
For the AI world.
And this research is crucial because as AI gets better at generating audio and video, we need better tools to evaluate it.
That makes sense.
Otherwise, we risk ending up with a lot of low-quality content that feels artificial and unconvincing. It makes me think about the future of entertainment.
Okay.
What if we get to a point where AI can generate entire movies, complete with realistic-sounding actors and dialogue?
That would be wild.
Okay, let's dive into something a little more technical.
All right.
This next paper is all about manipulating audio at the most fundamental level, the sample level.
The sample level.
Now, I have to admit, I don't fully grasp what sample rate means in the context of digital audio.
Sure.
Can you give us a quick breakdown?
Yeah, of course. So imagine you're trying to capture a sound wave digitally.
Okay.
The sample rate is how many times per second you take a snapshot of that wave. A higher sample rate means you capture more detail.
Gotcha.
Which generally leads to better sound quality.
So a higher sample rate means a richer, more accurate representation of the sound.
Yes. Exactly.
The papers we're looking at here, resampling filter design for multi-rate neural audio effect processing, and interpolation filter design for sample rate independent audio effect RNNs.
Got it.
They're about overcoming some limitations of traditional audio processing tools.
Limitations.
What kind of limitations?
Well, older tools are often tied to specific sample rates. Which can be a problem if you need to change the sample rate later on.
Oh, that makes sense.
For example, you might record something at a high sample rate, but then need to compress it to a lower rate for streaming online. That conversion process can introduce distortions or artifacts, degrading the sound quality.
So what are these researchers proposing?
They're developing ways to make audio processing more flexible. So you can change the sample rate without losing quality.
So it's like being able to zoom in and out of a sound wave without losing any detail.
Exactly.
That's a really cool analogy. It makes me think of those high-resolution photos where you can zoom in and still see incredible detail. And this technology could open up a lot of creative possibilities for musicians and sound designers.
For sure.
Imagine being able to create unique audio effects by manipulating the sample rate in real time.
That would be awesome.
It's like giving them a whole new set of tools to sculpt and shape sound.
I love that analogy.
Okay, for our last paper in this segment, we're going back to the intersection of AI and music.
Right.
We're looking at Music Lime, explainable multimodal music understanding.
Music Lime.
What's got you excited about this one?
Well, this research is all about making AI more transparent and understandable.
Okay.
Which is incredibly important as AI plays an increasingly large role in music creation and analysis.
Explainable AI is something I'm really fascinated by.
Yeah,
It seems like there's a lot of mystery surrounding how AI systems make decisions,
for sure.
especially when it comes to something as subjective as music.
Right.
So
Yeah.
instead of just accepting the AI's output,
Right.
we can actually see its thought process.
Yeah, we can kind of peek under the hood.
But why is this so important?
Well, think about it this way.
Okay.
If we don't understand how an AI model is making decisions about music,
Right.
we can't be sure that those decisions are fair and unbiased.
I see what you mean.
Yeah.
We need to make sure that AI systems aren't perpetuating existing biases
Right.
or making decisions based on factors that we don't fully understand.
Exactly.
Music Lime is a big step towards making AI more transparent and accountable in the world of music.
Definitely.
It helps us understand how AI is hearing and interpreting music, which is essential if we want to use AI responsibly and ethically.
Absolutely.
Wow, we've covered a ton of ground in this first segment.
I know, right?
It's amazing to see the sheer breadth of innovation happening in the world of audio.
It's incredible.
It feels like we're on the cusp of some major breakthroughs that could fundamentally change how we experience and interact with sound.
For sure.
And we're just getting started.
Oh, yeah, there's so much more to come.
In our next segment, we'll delve even deeper into the research that's shaping the future of audio,
I'm excited.
exploring topics like AI-assisted speech recognition,
Okay.
advanced audio compression techniques, and even more innovations in 3D sound.
Awesome.
So stay tuned for more mind-blowing discoveries as we continue our deep dive into the world of audio tech.
I can't wait. Welcome back to our deep dive.
All right, so for this next part,
Okay.
I want to focus on something that combines several themes we've touched on already.
All right, like what?
AI,
Yeah.
efficiency, and really pushing the boundaries of what's possible with audio processing.
Sounds intriguing.
It's called Efficient Audio-Visual Speech Processing via MUOE, Multimodal Training and Unimodal Deployment.
MUAE.
Okay.
Now, I know that title is a mouthful,
Yeah, it is a bit of a mouthful.
but stick with me.
Because the concept is really cool.
Right.
So basically, it's a way to train AI systems using both audio and visual cues, but then let them operate efficiently using just one of those cues during deployment.
Okay.
So think about a speech recognition system.
Okay.
During training, it might use both your voice and the movements of your mouth
Right.
to learn how to recognize speech patterns.
Yeah, that makes sense.
But in the real world,
Yeah.
it might only have access to your voice,
Uh-huh.
like in a phone call.
Right.
So it's like giving the AI all the information it needs to learn,
Okay.
but then stripping it down to the essentials for real-world use.
How's that clever?
And the key to this is something called TAME,
Tame.
which stands for Temporally Aligned Modality Feature Estimation.
Okay.
Basically, TAME allows the AI to estimate the missing modality, in
Right.
this case, the visual information,
Right.
based on the modality that is available.
So even though the AI is only receiving audio input, it can still use what it learned from the visual cues during training
Exactly.
to improve its accuracy.
It means we can build more efficient AI systems
Wow.
that are just as accurate as their bulkier counterparts.
That's a big deal.
This could be huge for things like mobile devices and embedded systems,
Right.
where processing power and resources are limited.
I see the applications already,
Oh, yeah.
like voice assistants that are even more accurate and responsive,
Yeah.
or hearing aids that can seamlessly adapt to different environments.
That would be amazing.
Right.
Speaking of adapting to different environments,
Okay.
our next paper takes us into the world of augmented and virtual reality.
AR/VR.
It's called Task and Perception Aware, Distributed Source Coding for Correlated Speech under Bandwidth-Constrained Channels.
Wow, that's a long one,
I know.
but it sounds interesting.
So this paper tackles a major challenge in AR/VR,
Yes.
transmitting high-quality audio from multiple devices over unreliable connections.
Okay.
Think about a virtual meeting where everyone is talking at once.
Right. If someone has a weak internet connection, it can really disrupt the flow.
Yeah, that's so frustrating.
So how are researchers trying to ensure a seamless audio experience in these challenging scenarios?
Well, they've developed a pretty complex algorithm that leverages the fact that speech from multiple sources is often correlated.
Correlated.
Yeah, it means that there's a lot of redundancy. So
So
instead of sending all the audio data from each person individually,
right.
They're finding ways to eliminate that redundancy.
Okay.
And reduce the overall amount of data that needs to be transmitted.
So it's like compressing the audio data, but in a really smart way.
Exactly.
But they didn't stop there.
What else did they do?
They also incorporated something called a perception-aware loss function into their algorithm.
Perception-aware?
Yeah.
What does that mean?
It means that the algorithm prioritizes preserving the parts of the audio that are most important for human perception. So even if some data is lost during transmission,
the overall quality and naturalness of the speech are maintained.
So it's like the algorithm is making intelligent decisions about which parts of the audio are most crucial to keep intact.
Exactly.
Even with limited bandwidth.
This research is a big step towards making AR/VR experiences even more immersive and realistic.
For sure.
Even when network conditions aren't ideal.
It ensures that you can clearly hear everyone in that virtual meeting.
Right.
Regardless of their internet connection.
Okay, let's switch gears again.
All right.
And explore a paper that delves into the emotional impact of audio processing.
Emotional impact.
It's called Interpolation Filter Design for Sample Rate Independent Audio Effect, RNNs.
Okay, RNNs.
This one is all about recurrent neural networks, or RNNs, which are great at modeling complex audio effects, like the distortion you hear on electric guitars.
That's cool.
But they've traditionally been limited by fixed sample rates.
So if an RNN was trained on audio with the specific sample rate, it couldn't handle audio with a different rate.
Right. That seems pretty restrictive.
It is.
But this research explores ways to make RNNs more flexible.
Okay, how?
By allowing us to change the sample rate during processing.
So instead of being locked into a specific sample rate, you could essentially fine-tune the resolution of the sound wave.
Exactly.
That's amazing.
And they do this by using special interpolation filters.
Interpolation filters?
Yeah. It's like having a magnifying glass that lets you zoom in and out of the sound wave to adjust the level of detail.
That's a great analogy.
What kind of creative possibilities does this open up?
Well, think about being able to dial in just the right amount of distortion on a guitar track.
Okay.
Or create entirely new soundscapes by manipulating the sample rate in real time.
That sounds like a lot of fun.
It is.
This could revolutionize how musicians and sound designers create and experiment with audio.
For sure.
It's like giving them a new palette of colors to work with, but for sound instead of visuals.
Love that.
Now for our final paper in this segment. We're circling back to the world of AI-generated music.
AI-generated music.
But this time, with a focus on making AI more transparent and accountable.
I like where this is going.
It's called MusicLime. Explainable multimodal music understanding.
MusicLime.
As we've discussed, AI systems for analyzing music are becoming incredibly complex.
They really are.
And it's often difficult to understand how they're making decisions.
Yeah, it feels like we're putting a lot of trust in these systems without fully understanding their inner workings.
It can be a little unnerving.
For sure.
And that's why research like this is so important.
Absolutely.
MusicLime is a tool that helps us understand why an AI model makes the decisions it does when analyzing music.
Okay.
It shows us which parts of the audio and lyrics the AI focuses on when predicting things like genre, mood, or even the emotional impact of a song.
So instead of just getting an output from the AI, we can actually see its thought process and understand its reasoning. This is crucial for ensuring that AI is used responsibly and ethically in the music industry.
I agree.
Imagine an AI system that is used to recommend new artists or songs.
Okay.
If we don't understand how the system is making its decisions, we can't be sure that those recommendations are fair and unbiased.
That's a good point.
Right.
It's like we need to hold these AI systems to the same standards of transparency and accountability that we expect from human experts.
MusicLime is a big step in that direction.
Yeah.
Providing us with the tools we need to understand and evaluate the decisions made by AI systems in the musical realm.
Well, we've covered a lot of ground in this segment.
We have.
From AI-assisted speech recognition to innovative approaches to audio compression. It's clear that the world of audio technology is constantly evolving.
It really is.
And pushing the boundaries of what's possible.
It's truly a golden age of audio innovation.
I like that.
And in our final segment, we'll explore even more cutting-edge research, including advancements in 3D sound,
emotional audio processing,
cool,
and the future of AI-generated content.
I can't wait.
So stay tuned. Welcome back.
All right, so we're back for the final part of our deep dive.
Yeah.
And you know, I'm still buzzing from all the incredible research we've explored so far.
Me too. It's amazing to see all the innovation happening in the world of audio.
Yeah, it feels like we're on the cusp of some major breakthroughs.
For sure.
Okay, so what have you got for us in this final segment?
Well, let's start by revisiting a topic we touched on earlier.
Okay.
Ambisonics.
Ah, yes, Ambisonics. That was the technique for capturing spatial information so you can experience sound coming from all directions, right?
Exactly.
Okay, so remind me, what's the paper we're looking at here?
It's called Ambisonics binaural rendering via masked magnitude least squares.
Okay, and what are the researchers doing here?
So they've developed a way to fine-tune the rendering process of ambisonics to create a more accurate and perceptually pleasing 3D sound experience. So it's not just about capturing the spatial information, but also about how that information is processed and delivered to our ears.
Exactly. They've figured out how to optimize the way sound waves are rendered in the ambisonics domain.
And what does that lead to?
It leads to a more convincing and engaging 3D audio experience.
This could be huge for things like VR and AR.
Oh, yeah, for sure.
You know, if you can make the audio truly immersive, it would take those experiences to a whole new level of realism.
Absolutely. This research is a big step towards blurring the lines between the virtual and the real, at least when it comes to sound.
Okay, I like that. Now, this next paper also deals with 3D sound.
Okay.
But it focuses on a very specific challenge.
What's that?
Creating realistic binaural audio for head-mounted displays using microphone arrays with a limited number of microphones.
Right.
I'm always amazed by how researchers can overcome seemingly impossible technical hurdles.
I too.
So what's the secret sauce here?
They're using a combination of clever signal processing techniques and deep learning to basically make up for the fact that these microphone arrays have a limited number of microphones.
So they're finding ways to capture a rich and detailed soundscape even with limited hardware.
Exactly. Think of it like this.
Okay.
Our ears are incredibly good at picking up subtle differences in sound that help us determine where a sound is coming from.
Right.
This research is all about replicating that ability.
Okay.
Using a limited number of microphones.
It's like they're giving these head-mounted displays superhuman hearing.
I like that.
What kind of impact could this have on VR and AR experiences?
Well, imagine being able to pinpoint the exact location of every sound in a virtual environment.
Okay.
Even if those sounds are coming from behind you or above you.
Wow.
It would create an incredibly realistic and immersive experience.
It would be like stepping into another world.
Yeah.
Okay, let's shift gears one last time and talk about a paper that explores the emotional side of audio processing.
Okay.
This one caught my eye because it deals with something I'm particularly interested in.
What's that? Movie dubbing.
Ah, movie dubbing.
I've always wondered how difficult it must be to dub a movie and still capture the nuances and emotions of the original performances.
It's a tough job.
It is.
It's a very delicate art,
Right.
and it's often difficult to get it just right.
So what's this paper all about?
So this paper introduces a tool called EmoDubber.
EmoDubber?
Yeah.
What does EmoDubber do?
It aims to give users control over the emotional tone of the dubbed voices.
Wait, so you're telling me they've developed a way to make a dubbed voice sound happier, sadder, or angrier, all at the push of a button?
That's the idea.
That's incredible.
It's like having a remote control for emotions.
Wow.
Imagine being able to fine-tune the performance of a dubbed actor to perfectly match the emotional arc of a scene, regardless of the original language.
This could revolutionize the way movies are translated.
For sure.
And make dubbed films much more engaging for audiences around the world.
Absolutely. It's about breaking down language barriers.
And making cinematic experiences more accessible and emotionally resonant for everyone.
Well, I think it's safe to say that we've taken a deep dive into the world of audio technology today.
We have.
We've seen how researchers are using sound to tell stories, evoke emotions, and create experiences that were once unimaginable.
Yeah, it's clear that the future of audio is full of possibilities.
I completely agree. I, for one, can't wait to see what amazing discoveries await us just around the corner. Thanks for joining me on this incredible deep dive.
It was a pleasure.